This reaction is an acid-base reaction. The one on the left, you see that there is an H being donated to the base. This whole thing I know is an acid because it has the ability to donate the hydrogen. And on the right-hand side, you can see that the green one, or the base, is the one that accepts the H. So therefore, this one is the base. This definition, or the Bronsted Lowry acid-base definition, says that acids are compounds that have the ability to donate the H+, also known as the protons, and the compound that accepts the H+ would be the base. So again, this would be the acid, because it's going to donate the H, and this would be the base. Now, of course, it's not always orange, blue, and green nice like this, but let's do a reaction that looks more realistic. Here's water and ammonia, and it forms into hydroxide and ammonium. So let's look very carefully of the water comparing on this side and on this side. Did it donate the hydrogen, or did it accept the hydrogen? There was a loss in a hydrogen, so it went from H2 to just an H. So because it has donated it, this water is considered to be an acid. Whereas if you look on the right-hand side of the equation, the product side, and comparing it to the reactant side, you see that the one of the hydrogen you gained, right? 4. So this is 3 and that one's 4. So this would be the base. So this acid-base reaction really is that transfer of that proton, or transfer of that H+ ion from the acid to a base. Now, please note that there is a component on the right side of the equation. So we have indicated that this was an acid and this is the base. And there's a double arrow, meaning that it is able to go into the right, but it is also able to go to the left direction, meaning that this guy will give it back the H to the OH minus. It's going to give it back to form into water, and this one ammonia. So if that's the case, then this would be considered to be the acid because that's the one that's giving the hydrogen, giving the proton away. So this would be the acid. That means when it's going in reverse direction, this would be the base because it's going to eventually accept the proton from the ammonium and forming back into water. But to distinguish the reactant side to the product side, on the product side, we add the word conjugate. On the left-hand side, reactant side, we don't write the word conjugate. Based on what we have learned so far, let's do a learning check. It says identify and label the Bronsted Lowry acid, conjugate base, the Bronsted Lowry base, and its conjugate acid in each of the following equations. Try this and come back and check the key. And here is the key.